Hi everyone, and welcome to Programming 2. We got another YouTube video here, and we're going to just start on two-dimensional arrays. So let's just create a class such as my array example, and we'll make a main method. I just want you to become a bit more familiar with two-dimensional arrays. So they're initialized using a special format or notation like this. My array is equal to new int, and you can choose the size. You can have it as a square array such as that, and then after that you can populate the array. You can say my array 0 0 is equal to 100, which assigns the top left value of the two-dimensional array to 100. If you're having trouble visualizing these things, and we can just simply instantiate an array as follows. We could have a two-dimensional array that just sets out the values like this. So we just say exactly what's going to be in this array. For example, a list of ones. Oops. That. Now this is still a square array, and it's populated completely by ones. So let's see if we can't just print this array out. How would we do that? Well, we need to first of all have a nested for loop so that we can access each row and each column. Okay, so for int row is equal to 0. Row is less than, how many rows do we have? 1, 2, 3, 4. We can get that number by just saying my array dot length. Remember that this is an array that stores arrays, so this calculates how many arrays we actually have stored here. So it's going to be 1, 2, 3, 4 arrays. And then we can say row plus plus. So that gives us access to each row. Now we want access to each column. So that's quite easy. We just make another for loop. For int I, we'll call it something useful. Column equal to 0, column less than my array. Now we want to ask each row how long it is, how many values are in there. So essentially we ask the first row, how many values do you have? It's 4. The second one, how many values? It's 4 again. So we ask row dot length, and then we increment the column value. Now all we need to do is do a system-out.print the my array row column, like that. And after each time we print out a row, we want to create a new line in the output. So you can do this just by simply outputting this carriage return or the empty string like that, because it always adds a new line to the end. So let's see what happens when we run this thing. Well, as you expect, we get the output that is according to this array. So 1, 1, 1, 1, we can, if we feel like it, add commas to it to make it a little bit nicer, like that. I'll leave it up to you to figure out how to get rid of those trailing commas. It's not difficult. You just check to make sure that you're not printing out the last one. And that's pretty much it. Now, what else can we do? Let's say we wanted to, this is just in a main method. It's not really that useful. Let's say we want to make a class, and we're going to call it 2D bit array, like that. Let's say it doesn't like that, so it's not really valid because there's a 2 on it. 2 dimension. Well, we'll just say 2D. How about just bit array? No, 2D is fine. It's tricky trying to come up with good good names for this. Okay, 2D bit array. Now what we're going to do is we're actually going, in this class, we're going to create a resizable bit array. So these are bits. Let's just say we are just storing ones and zeros in it. It could even be booleans if you wanted, but for now we're just going to have this as a private int myArray. We'll call it. Oh, I've got a better idea. Bitgrid. We're going to rename this to Bitgrid. Much better. Okay. Bitgrid it is. So let's just say that we can instantiate this public Bitgrid, and we give it a size, int. It's always going to be square, let's say, so we're just going to say size, and it's going to be a, or even n, it's going to be an n by n Bitgrid. So this dot Bitgrid is equal to new int n. And perhaps we set it all initially to ones. So we can write a method that will fill the grid. Much like this, actually. So what we have right now, let's just, we already have this toString method here, so we can make a toString method. And instead, of course, printing out something to the screen, we're going to construct our grid string. Initially, it's going to be empty. So instead of printing out like that, I'm going to just simply say grid string plus equals all of that. So I'm just creating a very large string ultimately, and right here grid string plus equals a carriage return or a new line, and then I just simply return grid string like that. Very easy. Let's see what it does. So I can create a new Bitgrid. Object Bitgrid maybe of size 4 like before, and then I can just go system.out.println Bitgrid dot, well, you don't even need that, just Bitgrid like that. And if I run that, we get similar output. Let's say I want to initialize all of these to 0, to 1 rather. I would like to just say Bitgrid dot initialize and give it a value, let's say 1. How would I do that? Well, I need to write a method that does that. So let's go in here. We can create a method like that in the Bitgrid class. And let's say, well, ultimately what we have to do is set them all to the value I. But I would want to call it value here. Call it bit value. Of course, you can set limitations. You can say bit value must be must range between 0 and 1. You might have even decided, instead of having a private int Bitgrid, you might instead want this to be Boolean. It's up to you. There's consequences to each decision that you make when you're programming. This is the easiest for me right now, so I'm just going to go with that. Let's try to initialize that. Again, it's going to be like a for loop, and in fact you can even cut and paste this here, but instead of creating a string, I'm actually just setting this dot bitgrid row column equals to bit value. So what does it look like? If I run that now, 0, now it's set to 1. I can set it to 99, 0, 99, etc., etc. Now, what sort of things we might want to do on a Bitgrid? Perhaps we want to sum some of the values in a row or sum the values in a column, that sort of thing. So let's work on two results here. We'll first look at summing, writing a method to sum the values of a row. Like this. Public, and then we return an int sum row, int row. Now we have to check, of course, first of all we have to turn the sum. Initially it's 0, turn sum, like that. So what do? Well, first we have to make sure that row is valid, and we're not going to get an array index out of bounds error. So all we have to do for that is to check if row greater than or equal to 0 and row is less than this dot bitgrid dot length, then we're okay. It's no problem. Then we're able to calculate this. And the way that we do it is just simply by summing up. Now you'll notice that row here, I'm not creating a nested for loop. I'm creating a just a single for loop that ranges over column here. And what I'm going to do is just sum up these values across this row. So this row is fixed. If I input row 1, then it checks to make sure that I have the correct length of Bitgrid, and then it just sets that this is fixed to 1, and it ranges across the columns. So let's try running that. And how about I initialize it to 1, and I do sum row number 1. And of course, as you expect, we would get 4. Of course, I could write a method to individually change some of the values in the Bitgrid. Public void set grid value int row int column int new value, and maybe we would have to check like that, check to make sure the rows and columns are actually within the range of the Bitgrid. We haven't really said that it necessarily the Bitgrid has to be square. It could actually be something else in the future, different size. So if that's the case, then we know that I can say this dot bitgrid row column equals new value. So let's try that out as well. There's the resulting code. I can space it out a bit. So let's say we set everything to 1, and we want to bitgrid dot set grid value row 1, let's say column 2, and the new value is going to be 0. We can print out the Bitgrid again, and we can sum this row as well. We should get 3, right, because we're setting one of these values to 0. So initially it was 0, we initialized it to 1, and then we set one of the values of the row to 0, and then we summed across that row, it's 0 again. So I encourage you to try out and create your own classes that manipulate two-dimensional arrays like this. There's a lot that can be done with them, and it's very useful, particularly if you're programming games. So that's essentially where this example might come from when we have 2 dimensions of 2D points, for example. Alright, so that's all for today, and I will see you in the lab. Bye!